A group of scientists has spent the winter in Antarctica and made an incredible discovery. I'll show you what that is, so be sure to stay tuned until the end. Welcome, guys. An entire winter in Antarctica. Can you imagine that? I interviewed one of the researchers who was there. It turned out to be really exciting. I want to expand the interview format on the channel a bit this year and maybe post 2 to 3 interviews per month. Let me know what you think about it. Do you think the interview format is a good addition to the channel, or do you prefer just the regular science news videos? I would be really interested to know what you think. Write it in the comments. And now we begin the interview. Feel free to give a thumbs up so that as many people as possible can see this exciting conversation. Let's go. So guys, today we are interviewing a super exciting guest, Dr. Martin Radenz, Antarctic researcher and atmospheric scientist, but you can probably explain that better right away. In any case, you were in the Antarctic and you work at the Leibniz Institute for Tropospheric Research, or TROPOS for short. I think I'll be hearing that abbreviation a lot today, and I just read that your area of expertise is the interaction between aerosols and clouds, especially in the Southern Ocean and Antarctica. That sounds super exciting. Maybe you could just describe in your own words what you do and what you research.
Yes, atmospheric scientist is a good description. I studied meteorology, and specifically we are concerned with the smallest particles that are in the air. The technical term is aerosols, which includes everything you can imagine. Sea salt that has been swirled up, desert dust, forest fire smoke, anything that is somehow anthropogenically caused, including soot and the like, floats in the atmosphere, is transported and goes up to heights of up to 15 kilometers. And that also affects the clouds. For a cloud to form, you need the tiniest impurities in the air for the vapor to attach to. And these are very complicated processes that are also difficult to observe. And that's where we're trying to gain a better understanding with our measurements.
And now I assume that Antarctica is a particularly good place for this aerosol atmospheric research. But why is that? So why don't I just sit here in Germany and do research on the aerosols in the atmosphere from here? What makes Antarctica so special?
The difference is in the details. The southern hemisphere has far fewer land masses and far more water. It is fundamentally much cleaner there. There are fewer emissions, less industry, no forest fires, and no desert dust. And that naturally also changes the interaction with the clouds. You might think fewer aerosol particles equals fewer clouds, but that's not the case. Instead, the clouds are simply different. For example, they have larger drops or rare ice crystals because there are many different types of aerosol particles. One type of aerosol particle tends to create liquid water clouds, but for that cloud to freeze, other aerosol particles are needed. And we are interested in these differences between the northern and southern hemispheres. We take measurements everywhere, in Germany, in northern Europe, also in the Arctic, and then also in the Southern Ocean.
Das finde ich spannend, dass man da so zwischen den Hemisphären unterscheidet. I find it interesting that there is such a distinction between the hemispheres. And I see that you have also conducted projects in the Arctic. I believe that the measuring station you have been working with was also in the Arctic before. Does that make a difference though? In the Arctic, I am in the northern hemisphere.
But there I have a different aerosol composition than in the Antarctic. You may have heard of the intertropical convergence zone, this belt that wraps around the equator, where there is a lot of high-reaching convection. And that is a very good barrier for aerosol. This exchange of air masses from the northern to the southern hemisphere, and vice versa, is greatly reduced as a result. This often only works with very specific processes. Volcanic eruptions, for example, bring a lot of aerosol over the tropopause, which is the lowest layer that influences our weather. Once the aerosol is there, it can spread globally. Everything that happens below is relatively well separated. Of course, there are a few exchange processes, but basically, it is relatively separate. And then you have this contrast that it is rather polluted in the northern hemisphere and rather clean in the southern hemisphere. There are also very polluted areas in the southern hemisphere. For example, in areas with frequent forest fires, it is also polluted there. But the further south you go, especially in the mid-southern latitudes, everything south of South America is very, very clean.
And the fact that there is generally more pollution in the northern hemisphere, I'm guessing, is because it is more densely populated, or are there more natural processes there as well?
Both. Well, there is much more human influence. The proportion of the ocean in the northern hemisphere is also significantly smaller, and wherever there are land masses, there are also very efficient aerosol emissions. Soot, mineral dust that is stirred up, that can also come from quite mundane arable land when it's dry. Then someone drives over it with a tractor, and then a huge dust cloud is immediately stirred up. Such processes happen. Or all kinds of biological material, for example, pollen.
Oh yes, I have a bad experience with that every summer.
Exactly, and they are actually also aerosols that then end up in the atmosphere. And there you have a lot more on land surfaces than on water surfaces.
Okay, I understand why Antarctica is such an important place for your aerosol research. That's a good segue because you were there. And correct me if I'm wrong, the project lasted a year and you were there for that long, is that right?
Exactly, the idea was to really spend a year there and cover each season once. If you go there and just spend 3 or 4 weeks observing clouds, you may well only get to see a small part of the weather there. And that's why the idea was to really cover everything. And in addition, there are very few measurements from the winter months in the Antarctic and in the southern hemisphere in general, because it is very difficult to get there then. And once you have gone to all the trouble of sending the measurement container, you naturally want to make the best possible use of the time there. One of the main reasons why we are interested in clouds in the southern hemisphere is that a great deal of solar radiation is reflected there, and we cannot yet determine the exact connection with cloud formation. At the moment, many climate models produce even fewer clouds in the Southern Ocean than actually occur. And when the solar radiation hits the sea surface and warms it up, because the seawater absorbs the radiation, the sea tends to get a bit too warm because of the lack of clouds above. There is also the question of the effects, and that is our scientific motivation for wanting to go to the Antarctic, to better understand all these processes between aerosols and clouds.
In die Antarktis, an die Küste der Antarktis gehen wollten, dort eben diese ganzen Prozesse zwischen Aerosolen und Wolken besser zu verstehen.
I already have a few questions in mind, I just have to organize them. During the Antarctic winter, it is less common for someone to be there the whole time. You immediately have an image in your head of an Antarctic researcher who is at a station like this, wrapped up in thick clothing. For most people, Antarctic winter sounds strange at first, because in their minds it is always winter. But that obviously makes a difference. Can you explain in more detail what the Antarctic seasons are all about and how they differ?
Kannst du das vielleicht nochmal genauer erklären, was es mit den antarktischen Jahreszeiten auf sich hat?
Das kommt immer darauf an, wo in der Antarktis man ist. Also Neumayer, die deutsche Forschungsstation.
That always depends on where you are in the Antarctic. The German research station is on the coast. That's about 70 degrees south, at the very bottom. It's comparatively mild there. In summer, it's -5 to 0 degrees Celsius. In winter, it's -40, and it's very changeable. That means you can only get there comfortably in summer.
Was das Problem ist, dass man eben eigentlich nur im Sommer dort in Anführungszeichen bequem hinkommt. Also der klassische Weg ist, man nimmt ein Schiff.
The classic route is by ship from Cape Town or Punta Arenas, from South Africa or South America. That takes about 10 days if everything goes well. And then you are at the station about 20 kilometers inland. The main problem is the sea ice, which gets about 1.5 to 2 meters thick in winter. And this band of sea ice grows again every winter and melts away almost completely in summer. But over a width of 1,000 kilometers, when you are at the station in winter, you no longer have 20 kilometers of ice in front of you, but suddenly 1,000. And of course, you can't get through with the ship. Well, you might get through, but it would take much longer and then the fuel wouldn't be enough.
Kann man nach Norden schauen und 1.000 Kilometer Meereis vor sich. Und da kommt man natürlich mit dem Schiff nicht durch. Also man würde schon durchkommen.
That's why most of it takes place in summer, and the ship usually only comes once to supply the station. So once a year, the ship comes and brings all the things you need there, from propellers, rolls of toilet paper, food, spare parts, vehicles.
Alle Sachen, die man da so braucht, von der Schraube über alle Klopapierrollen, über Lebensmittel.
And the scientists who work there from about November to the end of February or the beginning of March now always come by plane, which is easier. It takes about 5.5 to 6 hours from Cape Town. But that only works in the summer months, because otherwise the weather's just too unpleasant.
Aber auch das funktioniert nur in den Sommermonaten, weil sonst das Wetter einfach zu unangenehm ist.
Wahnsinn. Das heißt, es ist immer noch so, dass man sagen kann, im Winter ist man dort im Prinzip isoliert. Also wenn dann eine Schraube fehlt oder
That's crazy. That means it's still the case that you can say that in winter you are basically isolated there. So if there's only a roll of toilet paper left, then it's rather bad. Let's get straight to your life there. Of course, I'm also extremely interested in that, but maybe we should start by explaining the scientific facts. That's actually our topic, namely what you measured there. Now I have to look it up briefly because I don't remember it. That means I probably pronounce it wrong. OCEANET-Atmosphere.
OCEANET, wie nennt man das? OCEANET-Atmosphere? Wie ist die Aussprache?
Ja. Ist so ein bisschen Englisch.
And this measuring platform was also used in the Arctic before in 2019 and now in the Antarctic, right?
War vorher 2019 aber was auch schon in der Arktis im Einsatz und nun in der Antarktis.
Wait, before we go on, have you already left a like and a comment? If you like this scientific content here and don't want to miss future interviews, then leave a subscription for the channel and activate the bell so that the evil YouTube algorithm doesn't hide the videos from you. And now on with the interview.
Genau, also das Projekt vorher war quasi
Exactly. In the previous project, we drifted across the North Pole with the German research icebreaker Polarstern. That was also a year long. But there we exchanged the people every 2 to 3 months because that was simply how it was set up. It was possible with a lot of effort. In the Northern Hemisphere, it is a bit easier to get to, so it's not that far from Tromsø to the North Pole.
kommt man da auch ein bisschen besser ran. Also von Tromsø aus zum Nordpol ist es nicht mehr ganz so weit.
Ja, da bin ich immer jedes Jahr.
Yes, I'm always in Tromsø every winter, but you've probably been there more than once, haven't you? I always sit in this pub where you somehow have to pay 20 euros for a beer and then imagine what it was like back then with the polar explorers, with Fridtjof Nansen and all that. It's kind of like your life now. So why don't you describe what this OCEANET is exactly? What can you measure with it? How can you imagine that?
Ja, okay. Ja, dann beschreib doch mal, was dieses OCEANET, ist das die richtige Aussprache?
OCEANET, ja.
OCEANET. Was ist das? Was misst man damit? Wie kann man sich das vorstellen?
You have to imagine it like a 20-foot shipping container, about the size of a truck. The advantage of that is that it contains all of our measuring instruments, which makes logistics very easy. If you know exactly how big and heavy the container is, it's easy to arrange the logistics. We know what kind of crane we need and how to place it on the ship, which simplifies everything. The idea is to have our measuring instruments, power supply, air conditioning, server, which also records the data, all in one relatively compact container, and to be able to send it all to other places, for example, to polar stations or other research ships.
Und was die Idee dahinter ist, ist eben, dass wir unsere Fernerkundungsmessgeräte, das erkläre ich gleich noch, dass wir die eben in diesem Container haben.
And to be able to carry out these measurements relatively easily there. We don't have to pack everything individually and send it somewhere else and reconfigure it, but have everything ready to go right away. This container simplifies things a bit. And what measuring instruments we have in it. That's basically all the equipment we need to characterize the atmosphere. First and foremost, we are primarily concerned with the lowest 10 to 12 kilometers, where the weather and climate mainly occur. And then, we use what is known as a LiDAR and a radar. With the radar, you send out a pulse of electromagnetic radiation, and then look at what comes back with an antenna. and from the time it takes, at what altitude it takes place. We then look at various properties, such as the total amount of energy that comes back. This gives us an idea of how many cloud particles there are. This has to do with what are known as radiative transfer calculations, which are a bit more complicated. But in principle, the result is a lot or a little. What you can also do is look at the phase. From that, you can even determine the speed at which these particles move. And what you also do is look at the polarization direction. The antenna has two receivers, and if different amounts come back, we can draw conclusions about the properties of the particles.
Und was man auch macht, ist die Polarisationsrichtung sich anzuschauen. Also diese Antenne hat zwei Empfänger und dann kann man eben sagen, okay.
And the LiDAR works in basically the same way, except that it doesn't take place in the optical range. We have a laser that emits 3 wavelengths, one in the visible range, so a greenish light that you can always see in the pictures, one in the UV at 355 nanometers, and one at 1064 nanometers. And then we look at what comes back with a very, very small telescope. The main mirror is only about 30 centimeters in size. And with that, we can see which aerosol particles are at which altitude, using different wavelengths, different polarization directions, and a few other features that we have built into it. And these measurements really do run 24 hours a day, 7 days a week. And what you then get is a time-height section across the atmosphere. You can really see clouds moving across the sky, what cloud particles you have, what kind of aerosol particles, how they interact with each other. And that's how you get a picture of how the atmosphere works above you.
Und darüber kann man sich dann eben ein Bild davon machen, wie die Atmosphäre oberhalb von einem funktioniert.
Verstehe. Und das also funktioniert.
I see. So the principle works the same everywhere, which means you did the same on the Polarstern. And how do you visualize the results? You've been doing this for a year now. Do you get the results immediately so you can work with them? Or do you do the analysis after the fact?
Ergebnisse, mit denen man arbeiten kann, oder macht ihr jetzt im Nachhinein quasi erst die Ergebnisauswertung?
Beides. Also,
Both together, we collected almost 20 terabytes of data. That is, of course, a relatively large amount of work. We have a data evaluation and a backup directly in the container, and then we transferred the data to the station again. The container is located 400 meters away, so we also backed up the data there a second time to make sure it wouldn't get lost.
Eben die Daten dort auch noch ein zweites Mal zu sichern, weil es doof wäre, wenn die dann verloren gehen würden.
Yes, losing 20 terabytes would be a bit annoying.
Etwas viel Aufwand für wenig Ergebnis.
Yes, it would have been a lot of effort for little result. In any case, we have different data levels, such as raw data, initially evaluated products, and then geophysically derived variables.
Geophysikalisch abgeleitete Variablen. Ein Teil dieser Variablen haben wir direkt jeweils danach.
We send some of these variables directly to Germany at night to evaluate them in real time, so to speak. The data is made available in a large European network. So we have already done the first evaluations.
Für verschiedene Standorte zur Verfügung gestellt werden. Das war quasi so dieses in Echtzeit weg. Und
now, in the follow-up, we are of course taking a detailed look at the data. We can't evaluate 20 terabytes in real time, but only the highlights and the most important products, so to speak. And everything else is now coming in retrospect.
Die Highlights und die wichtigsten Produkte, die hat man dann sofort sich angeschaut und dann die Details, die macht man jetzt erst im Nachhinein.
But that means that your work on site consisted, on the one hand, of operating the OCEANET measuring device, of course, but then also of working on the data on site.
Exactly, so primarily to back up the data. When you take measurements there, you naturally want the equipment to be set up optimally, so that you can be sure that the data quality is high enough. Because nothing is more annoying than measuring for a year and then realizing afterwards, okay, I didn't adjust something properly or didn't connect a cable.
Yes, that would be the YouTube equivalent of when I shoot a video and at the end I realize, crap, there was no SD card in it or something.
Exactly, and you want to realize that within a few hours and not months later.
Ja. Okay, also da nehme ich jetzt, die 12 Monate sind ja nun schon längst
Yes.
vorbei.
Okay, so I gather from this that the 12 months have been over for quite some time. You have already worked on the data, which means you probably already have the first results, or at least an idea of the direction the results are taking. What would you say are the most important results from this year's research work, if that's a fair general question?
Falls man das so sagen kann. Das ist eine sehr allgemein gestellte Frage.
Also was man auf jeden Fall sagen kann und was wir auch in unseren Daten sehen,
Well,
2022 war
what we can definitely say, and what we also see in our data, is that 2023 was a very, very unusual year in the Antarctic. It was the year with the lowest sea ice extent on record since the 1970s. Since the first satellites, we have had an idea of how far the sea ice extends. 2023 was the record minimum. Of course, this also means that there is a large source of energy. So the ocean always brings warmth, then brings moisture, and that, of course, influences the weather. And what we saw is that this year was actually already too warm in terms of temperatures, significantly warmer than the long-term average. It was also a bit too humid, with more precipitation than usual. The station is located on this glacier. The effect of this is that the accumulation of snow has increased, so that a lot more snow has fallen on top than usual. That means that, for the time being, it's good news. More material is forming. We have also seen this in our observations. An enormous amount of snow has fallen and then remained on the ground. We were also able to show this with our measurements. What we also saw, of course, were very warm temperatures in the middle of winter. At the beginning of July, there was a very strong warm air advance. Normally, the temperatures are around -25, -30 degrees on average. Of course, it always fluctuates a bit, but that's the average temperature. But what happened at the beginning of July was that the temperatures rose to just below freezing. One morning, the thermometer was at -2 degrees. That is absolutely unusual. It was the warmest July observed since the 1980s. Of course, that also had an influence on precipitation. Normally, snow falls at temperatures between -5 and -10 degrees Celsius. Snowflakes, all normal. What happened then was that the air became so warm that there was a kind of drizzle. This is normally known as freezing rain. But in the Antarctic, it is actually very, very rare. It has sometimes been observed in summer, but in winter we simply didn't have the data. What also happens, of course, is that liquid water forms, but then freezes immediately. It then freezes on the station or on the surface of the snow. That was an unexpected measurement result for us. We only knew it from the summer, but now we were able to observe it in the middle of winter.
Solche Prozesse, die man eigentlich eher aus anderen Gegenden und aus dem Sommer kennt, auch mitten im Winter beobachten kann.
Mhm. Und ich nehme an, ihr habt sicherlich dann auch die Datensätze.
I assume you have also compared the data sets with those from 2019 from the Arctic. Is it even possible to compare them? And if so, what did this comparison show? What are the differences? You already explained a bit about the difference between the Arctic and the Antarctic, but especially with regard to this anomaly, what conclusions do you draw from it?
Gerade im Hinblick auf dieses Anomaliejahr, kann man da irgendwas sagen und welche Erkenntnisse aus dem Vergleich ziehen?
Da sitzen wir tatsächlich gerade noch dran.
Yes, we are still working on that. The comparative evaluation is still ongoing. What is actually quite interesting is that we still measured aerosols there. It's not as if it's completely clean. There is still a lot coming from the sea at the measuring station, including some that is of biological origin. But of course, it is much cleaner than in the Arctic. In winter, in particular, forest fires in Siberia and northern Canada could be seen in the central Arctic. We didn't have that at the Antarctic station. That's one of the special evaluations we've already done. The analysis of cloud properties is still pending. But in any case, it is already possible to see that both the Arctic and the Antarctic are changing very, very quickly and faster than one might think. There are many such small pieces of the puzzle that we are now putting together internationally in a team. Until 2016, we thought that the Arctic was actually still very little affected by climate change, but there are already major changes there.
2016 gedacht hat, dass die eigentlich vom Klimawandel noch sehr wenig berührt ist, dass es dort inzwischen auch schon starke Änderungen gibt.
The biggest influence there is, of course, anthropogenic. That's logical. Nevertheless, I'll ask, did the Hunger Tonga eruption have an influence on this? It was in 2022, this underwater volcanic eruption in the South Seas, of which there are also spectacular images that I watch on YouTube at least once a week. Could that have at least somehow contributed to this anomalous year?
Ja und nein. Also in der Troposphäre,
Yes and no. Well, in the troposphere, probably not anymore, at least according to our current analysis. In the stratosphere, i.e., everything above 9 to 12 kilometers, a strong volcanic eruption can introduce aerosol into the stratosphere over the long term. We know this from Pinatubo, for example. We were actually able to observe the aerosols, a thick layer of aerosols, that was present between 12 and 15 kilometers throughout the year. And, as you would expect from an underwater volcano, it also brought an extremely large amount of water vapor into the stratosphere.
Einiges an optischer Dicke mitgebracht hat. Und was die natürlich auch mitgebracht hat, du hast es eben angedeutet, es war ein Unterwasservulkan, die hat extrem viel Wasserdampf in die Stratosphäre eingebracht. Und das
And comparative studies are still being carried out on this. The ozone hole was definitely affected. The increased moisture leads to the formation of biopolar stratospheric clouds, which influence ozone chemistry. The ozone hole in season 23 was relatively large and formed early. But of course, it's always difficult to assess. You normally have to look at several years. But it is true that this extreme water vapor content in the stratosphere definitely contributed to it. And then, of course, there were the sulfate aerosols, which we also observed. So it was a special year not only in the troposphere, but also in the stratosphere.
Dass das nicht nur in Bezug auf die Troposphäre ein besonderes Jahr war, sondern auch auf die Stratosphäre.
So gesehen war es ja eigentlich ein Spitzenjahr, um dort zu sein, sage ich mal, weil man dann noch dieses besondere Ereignis mitnehmen konnte und mitmessen konnte.
From that point of view, it was actually a great year to be there because you could then capture this special event directly in the data. So now we have already learned a great deal about how you research this, how the OCEANET measuring device works. I imagine it's not easy to conduct such intensive research in this harsh environment. Did you sometimes encounter difficulties that you had to deal with, or was it basically easy going every day? We measure, we evaluate, done.
Musstet? Oder war das wirklich so, ja, jeden Tag im Prinzip easy going, wir messen, wir werten aus, fertig?
Naja, man macht sich da ja vorher Gedanken und denkt und fängt dann natürlich auch an zu konzipieren.
Well, you think about it beforehand, and then, of course, you start to think about what the possible scenarios are, what could break, where we might need to make a few adjustments, so we've prepared well for that. But then, of course, it's always different on site, and you can't plan for everything.
Für alles kann man nicht planen, also so, ich sage jetzt mal, wir hatten dann für diese Radarantenne, also so eine
So, I'll say now, we had built a housing for this radar antenna, which is an antenna with a diameter of 1.20 meters, to shield it a bit from the worst weather conditions. The very first version was good, but it wasn't completely snowproof. And then we had a storm and somehow almost 80-knot winds, and you just realized that snow is coming in through the smallest cracks. And that meant that you just had to go there after the storm and clear the snow out of the antenna. After that, we properly sealed our device and never had a problem again. That was once in April, but then it lasted the whole winter. But that was kind of the one iteration that we still had to go through.
Hat es den ganzen Winter durchgehalten, aber das war quasi so diese eine Iteration, die man da noch gehen musste. Und so war
And it was the same with some of the little things, so it all worked surprisingly well. But it helped to be on site so that we could still do the fine-tuning and see if there was anything we could improve here and there. Temperature stability is also an important issue. If you have a container that is somehow stored at an ambient temperature of minus 20 degrees, but you want the temperature inside to be between 17 and 18.5 degrees, that can sometimes be a bit tricky.
17 bis 18,5 Grad sind, funktioniert schon, aber ist ein bisschen tricky manchmal.
Ja, das glaube ich dir gerne. Dann lass uns doch gerne jetzt zum Abschluss noch ein bisschen auf deine persönlichen Erfahrungen kommen, wie das Leben in
Yes, I'm sure it is. Then to wrap up, please share a little about your personal experiences of what life in the Antarctic was like from your perspective. I imagine spending such a long time in such an extreme environment would be incredibly formative. You said that it's difficult to get out during the Antarctic winter. What was it like for you? How many people were you with? What is a typical day like in the Antarctic?
Dort und wie kann man sich so einen Tag in der Antarktis vorstellen? Vielleicht kannst du ein bisschen aus dem antarktischen Nähkästchen plaudern.
Yes, you have to distinguish between summer and winter. The station is operated by the Alfred Wegener Institute in Bremerhaven. That means they take care of all the logistics and the long-term measurements. In other words, everything that has been running for over 40 years now is operated and evaluated by the Alfred Wegener Institute, and we are only involved as an additional project, precisely because of our expertise in remote sensing. In the Antarctic, summer is rush hour. There are 50 to 65 people at the station who do everything that needs to be done in the summer. Everything is serviced once, the whole station from top to bottom. There are a lot of technicians on site. Then, because the station is on the glacier, it has to be raised. There is about a meter of snow accumulation per year. That means that the station has to be raised at least a meter every year to keep it from sinking. Then there are various outstations, so up to 120 kilometers in the surrounding area. These are also serviced once a year. And then there are various projects that mainly take place in the summer. For example, biological research at the penguin colony or a wide range of other things. All that happens in the summer. And with 50 people, the station is packed. There's always action.
You almost wish for a bit of solitude.
Yes, it is also the case that you have to see that you somehow find a balance. In winter, it is completely different. At the beginning of March, everyone is gone. Then, there are only 9 or 10 people at the station, who then stay virtually from winter until the end of October or the beginning of November. It's almost a mixture of caretaking and science, because you maintain these series of measurements that have been there for a long time. And because you are also there to ensure that this station continues to run, and that it can serve as a base for the summer season again next year. That's why it's different then. In winter, it's a bit quieter. But you also have a lot of tasks then. But also a lot more freedom. And then there are usually 5 scientists and 3 engineers, a doctor and a cook for all the meals. You also have a lot to do with routine measurements. I worked a lot with the meteorologist. Shout out to Lucas if he sees this.
Und das ist wirklich ganz klassisch. Der geht dann alle 3 Stunden vor die Tür, schaut sich an, wie das Wetter ist. Gibt's Wolken, gibt's Schneefall, gibt's irgendwelche besonderen anderen Erscheinungen?
And that's really quite classic. He then goes outside every 3 hours, looks at what the weather's like. Are there clouds? Is there snowfall? Are there any other special phenomena? Measures temperature, looks at wind direction, and then enter everything promptly into the module. Then he does a radio sonde ascent once a day. And we took turns on that to some extent. So I also took over something from him so that he could have a break of more than 2 hours. And what I did then was usually have a normal breakfast in the morning. Then check the container to make sure that all the measurements were running, and then check that everything was okay, that the data had been uploaded overnight. We then also live in UTC time, so at noon we took turns with the probe, and then the first part of the day was basically done, and then you just looked at what was on the agenda, whether it was more data work, where you had to look at where there was a problem in data processing, or whether you had to do some kind of maintenance on the measuring device, or whether someone else might need help. So it was also the case that if the engineers who had to maintain the station's operations somehow had a bigger thing to do, then it was sometimes said, "Can someone help out?" And then you helped each other. And then at some point in the afternoon or evening, you might have made a weather observation, and of course you kept checking to see if the measurements were still running.
Alarme auflaufen. Das heißt, wenn jetzt irgendwas nicht funktioniert hat, hat man dann ist es irgendwo aufgeploppt und dann hat man quasi sofort das gemacht und das im
It could
Zweifel
also
dann
happen that
auch
alarms
abends
went
und
off.
nachts. Also, das war dann schon so,
So if
dass
something didn't work,
Rettungsarbeit im
it
Vordergrund
popped up
steht.
somewhere, and then you had to fix it
Was wir dann noch
immediately.
gemacht haben, so als
And if in
quasi
doubt,
das
then
der
also in the
normale
evening and at
Tagesablauf,
night.
5 Tage die Woche.
So the work is in the
Und,
foreground,
dann gibt's
and
natürlich
what we
noch
did then was this
zusätzliches
normal
Messprogramm.
daily
Also,
routine.
was wir relativ viel gemacht
5
haben, war
days a
das
week,
sogenannte,
and then, of
Nähreismessen. Das
course,
heißt,
there was
wenn
the
das
additional
Neumayer
measurement
nah an der
program.
Küste steht, kann man wirklich
For
auch
example,
von
we also
dieser
measured sea ice.
Gletscherzunge, auf der man da wohnt,
The
also das ist
station
auch
is
so
close to
2
the
Kilometer
coast
dick,
and has about 2 meters
kann
of
man
ice
auch
below
aufs
it,
Meereis fahren. Das
but you
ist
could
so
also quickly
am
drive
Anfang der
out to the
Saison
sea
70,
ice
80
and
Zentimeter
take
dick, am Ende der
measurements.
Saison fast 1,5
At the
Meter.
beginning of the
Und da gibt's 'n
season,
Messprogramm,
the
da
ice
geht
is
einmal im Monat
70 to
diese
80
Nähreismessen
centimeters
misst
thick,
und dann ist
and
dann
at the
so
end
das
of the
ist dann so 'n
season it
bisschen
is
wie
almost 1.5
die
meters thick,
Polarforscher Skitour,
and you
wo man
measure that
wirklich
every
auf
month.
so 'nen Motorschlitten steigt, sein ganzes Equipment auf 'n Schlitten packt und dann den ganzen Tag lang draußen, ist und da Löcher ins Eis bohrt und Eisdicken misst und Wassertemperatur misst.
Then
Und da gibt's
there's
so
the
'ne Art,
polar research approach,
Standardmessung, die wird jetzt
where you
auch,
actually get on a
über 10
snowmobile,
Jahren
put all
gemacht,
your equipment on the
dass man
sled,
eben,
and then you're out there all day drilling holes in the ice and measuring
Kilometer
ice
lang
thickness and
6
water
Jahr
temperatures.
alle 3,
That's
4
been a kind of
Kilometer eben
standard
Eisdicken
measurement
misst
for
und das
10
wird auch
years.
in 'ne
You then travel 30
Datenplattform überführt,
kilometers
damit
and
man,
measure the ice thickness
da
every
eben
3
Unterschiede
kilometers.
oder
Then you can also
Entwicklungen
see
in
the
der
development in the long-term data.
klimatischen Mittel erkennen kann.
Mhm. Ja, habe ich dich ja am Anfang korrekt vorgestellt, als ich gesagt habe, Atmosphärenforscher und Antarktisforscher. Ich meine, damit bist du
Ja.
quasi offizieller Polarforscher.
So, in addition to being an atmospheric and Antarctic researcher, as I introduced you, you're also a polar researcher in that you have studied the sea ice there. And I imagine that you grow together as a team when you are there for so long, just 9 or 10 of you, and everyone is a jack of all trades. As you said, you help out wherever you can, right? I gathered from what you said that you like the winter better than the summer. Is that right?
Wie würdest du das sagen?
Ja, ist beides interessant, aber wenn man aussuchen muss, ist der Winter schon
Both are interesting, but if you have to
besser.
choose,
Man hat
winter is
einfach mehr
better.
Zeit. Es ist jetzt nicht so, dass
You
man
simply
da
have more
die ganze
time.
Zeit Druck hat, das
It's not like you're under
messen
pressure all the
in
time
den
if you're
2
only there in
Jahren.
the summer.
Man hat 6 Wochen
If
Zeit,
you're only there
eine
for
Woche
6
Anreise,
weeks,
eine Woche Abreise,
1 week
dann
of travel,
muss der
1 week
Rest
of departure,
hundertprozentig funktionieren.
and then the
Im
rest
Winter
really
kann
has
man
to
da
work
mal sagen: „Okay, ich
100%.
habe jetzt vielleicht
In winter,
mal
you can
'nen
say,
Tag
okay,
mehr Zeit, um
I
dieses
might have an
Problem
extra day to solve this problem.
Ja.
Und man kann
You can take it a
auch
bit
'n
more,
bisschen mehr
especially the nature you have
aufnehmen.
down there.
Also, so grade dieses
What is totally impressive
die
is, of
Natur, die man
course,
da
the
unten hat,
polar
also,
night. It's
was
dark for
total
almost 3
beeindruckend ist,
months
sind
at the
die
station
Polare
there.
von Neumayer
Ja.
bis
The
fast
northern
3
lights are
Monate
also impressive, of
dunkel.
course.
Ja.
And then, of
Polarlichter,
course,
das ist schon
there are the
beeindruckend. Und
storms.
natürlich auch die Stürme. Also,
You experience wind
da
speeds
erlebt
that
man
would
dann
otherwise
an
prevent you from going
Windgeschwindigkeiten, würde
outside.
in Deutschland
And then you
über die
can't
Kühe
work
gehen.
there normally either.
Und dann
But there's
kann
always
man
something
dort
to
auch,
do,
ja,
and
nicht
then,
normal
when in doubt,
arbeiten, aber es
it
gibt
just
immer
has
was
to
zu
be
tun
done.
und dann, muss
But
sich
then
im
there are
Zweifel auch
situations in
erledigen.
which you
Das
can't
aber
get
das
out
sind so
because the snow is being
Situationen,
blown
wo
up.
man wirklich,
You might know
draußen
this from
ist, sozusagen,
popular
dass
science
der
literature
Schnee
or from old
aufgewirbelt
reports,
wird
this whiteout.
und man
That the contrast
kennt man
between the
vielleicht selbst
ground and the
aus
sky really disappears, you have no
Literatur, so aus
chance.
alten Berichten, dieser Whiteout, dass wirklich der Kontrast zwischen Boden und Himmel
Ja.
verschwindet. Also, man wirklich geht durch 'ne weiße Suppe.
Ja,
Man hat
also
dann
Just like Amundsen.
Amundsen-mäßig, ne?
But
genau,
then you
man
always
hat
have a
dann
rope
so 'ne
stretched along a
so 'ne
post,
so 'n Seil, das
wherever
da
you
an
need to
Pfosten
go,
entlang
to
gespannt
the
ist,
measuring
dort, wo man
container
hin
or
muss.
to the
Also,
meteorological
eben
measuring
zum
station or to the
Messcontainer
air
oder
chemistry
dann zu
observatory.
der meteorologischen Messstation oder zu dem
Mhm.
luftchemischen Observatorium gibt's dann immer so
There
'ne
is
Leine
always
und
a
dann kann man
rope,
da an der Leine
and then you
entlang
can
gehen
walk
und
along
dann,
it, almost no matter how
egal,
windy it is.
wie windig
And
es
that's pretty
ist.
impressive when you
Das ist
feel how much power
beeindruckend.
there is in
Da
nature.
merkt man auch,
Wahnsinn, ja.
wie viel
Das
Kraft
stelle
in
ich
der
mir
Natur
unfassbar
steckt.
Ja, total. Also, das stelle ich mir unfassbar beeindruckend, wie du gesagt hast, vor.
Yes, totally. I imagine it's incredibly impressive. And to see the Aurora Australis, I would really give a lot for that. I mean, it looks exactly like the Aurora Borealis, but still it feels different to see the Aurora over Antarctica. To conclude the interview, it's a very unscientific question, but what was the best moment of your 12 months in
Das
Antarctica?
ist eine sehr unwissenschaftliche Frage. Aber was war der schönste Moment deiner 12 Monate in der Antarktis?
Ist schwer zu sagen,
That's hard to
also, da
say.
gibt's
There were
viele
many
schöne
beautiful
Momente.
moments.
Also, ist natürlich
One that
einmal
really
die
stuck in my
Antarktis.
mind
Es
was
gibt
actually the
tatsächlich
first time we
sehr
saw the
warm, wo die
sun
Sonne
again
selbst
after the
gehabt
polar
hat, der
night.
Polarnacht. Da waren wir
We happened to be
zufällig gerade
taking
als
sea measurements
Meeresmessung.
at the time,
Ähm,
and the
da ist
weather,
wirklich war
it
das
had been
Wetter
too cloudy for
Tage
days,
vorher war es
so
schon
all you
grell,
could
hat
see was a
hat man
slightly lighter gray. And that was really the first day that you could actually see the sun just over the horizon.
man wirklich die
That
Sonne
was
knapp
pretty
wieder über den
impressive.
Horizont hat kommen sehen.
Mhm.
Das war dann schon beeindruckend.
Ja, das glaube ich. In Tromsø wird das doch irgendwie, feiern die das mit so einem Gebäck irgendwie. Ich glaube, da gibt's noch so
Yes, I
komische
believe that. In
Puddingteig
Tromsø, they celebrate it somehow with a pastry. They have a pudding on the day the sun comes out again. Okay, let's finish up with a look at what's going to happen in the future. You're now continuing to analyze the data from OCEANET. What's next for you? What are your most exciting research projects for the future? And will you be returning to Antarctica?
Forschungsprojekten der Zukunft und steht es an, dass du wieder in die Antarktis zurückkehren wirst?
Im Moment noch nicht konkret.
Not yet,
Das kommt immer ein bisschen
specifically.
darauf an, wie
It always depends a
die
bit on the current
Projektausrichtung
project situation.
Wissenschaftsbetriebe
The
sind
scientific
sehr-
community is
sehr
always very
kurzfristig
dependent on
finanziert und
third-party
nicht genau,
funding,
was kommt.
so we just have to see what happens.
Was wir
What
jetzt
we are
während
planning
der nächsten
specifically
Jahren
for the near
machen, eine
future
ähnliche
is
Messkampagne
another
in
similar
Neuseeland,
measurement campaign in New
die dort
Zealand,
so ein bisschen mehr den Kontrast
to look at the
zwischen,
contrast a bit more
was kommt
and to
vielleicht
see what
auf
might come from the Australian
Aerosolen
continent
Australien
in the way of
kommen.
aerosols.
Wie wird es dann in den
How is
Zukunft
it then
weiter?
transported
Was
further in
passiert?
the
Das ist
southern
so eines der
oceans?
nächsten Dinge, die
That is
anstehen.
one of the next
Dann, was
things
auch
on the
gerade
agenda.
uns sehr beschäftigt, ist
Then,
der Earthcare
something that is
Satellite.
also
Also
very important to us
unsere Messgeräte
is the EarthCare
gerade
satellite,
wieder auf einem
which is
Satelliten,
basically our
das
measuring
im
instruments,
Sommer
radar,
gestartet
and
wurde.
LiDAR on a
Da können wir
satellite
jetzt die
that was
ersten
launched by
Daten
the
und das ist auch
ESA
was, was wir
last
uns
summer.
eben auch anschauen,
The
was
first
die
data
was
is
die
now
da
coming in,
simuliert,
and
also
we are
was
looking at what the
wie sie
satellite
dort
sees
Satellitenwolken
and the
anschaffen,
cloud
wie sehen wir die am
properties,
Boden. Und dann
also
kann
in
man eben
comparison to
mit
the
diesen
ground data.
Beobachtungen den
And then you can
geografischen
open up
Kontext sehr
the
viel weiter
geographical
ausweiten. Also
context
ist nicht mehr an
much
einen Ort
further
gebunden,
through these
sondern kann
satellite
relativ kurzer
observations.
Zeit auch
So you're not tied to one
Unterschiede zwischen
location.
Regionen
This
feststellen. Und
topic
das
will
ist
probably occupy us for the
so ein
next
Thema,
few
das uns die
years.
nächsten Monate, Jahre beschäftigen wird.
Ja, super spannend. Da haben wir ja dann wirklich die Überschneidung auch zwischen Astronomie und eurer Forschung. Ich meine, Atmosphärenforschung ist natürlich immer zum Teil Astronomie.
Yes, super exciting. This is where we really have the overlap between astronomy and your research. Atmospheric research is, of course, always partly astronomy. In any case, it sounds like we could do another exciting interview on the topic in the future, but I don't want to take up any more of your time today. I'd say we've now learned a lot about the Antarctic, life there, atmospheric research, and the OCEANET measurement platform. If you still want to leave a message for Dr. Radenz, please write it in the comments section so that he has enough to read on his next trip. I found it really super exciting. It is on my bucket list to travel to Antarctica sometime, and this has motivated me even more to do so. Of course, I will never make it there as a scientist like you, but only as a simple tourist. Otherwise, thank you very much for the interview, and I would say we'll talk next time you have some more exciting research results.
Dann bedanke ich mich sehr für das Interview und ich würde sagen, wir sprechen dann das nächste Mal, wenn ihr weitere spannende Forschungsergebnisse habt.
Sehr
I'd
gerne.
love to.
Und,
And thank you
vielen
for your
Dank auch für
time.
deine Zeit.